In this video, I would like to explain data mining using decision trees. Okay, for your practice, we're going to use a Chapter 7 database. Okay, so as you know, go to Start and open a SQL Server Management Studio, and then find Chapter 7. Okay, this database was downloaded from your textbook website. So go to Chapter 7. Okay, and then find a gbo.collegeplans. So this is a table, this is the data we are going to use to practice data mining using decision trees. Okay, so we will use this college plans table for two problems. The first one is classification. So let's look at the data over here. So as you can see over here, so we have the data of gender, parent income, IQ, and the parent encouragement, and also the college plans. So using these data points, we want to predict the person is likely to go to college or not. So like plans to attend or does not plan to attend. So basically supervised learning using these labels. So we want to classify applicants whether they are likely to attend a college or not. So the input data will be gender, parent income, IQ, and parent encouragement. The second type of problem we are going to solve here will be the regression. You probably learned regression in some statistics class. We're going to do regression in a very easy and powerful manner using decision trees. So in this case, we're going to use a decision tree to create a regression equation between, let's say, parent income and IQ. So this one is just for the purpose of a demonstration. So we are not saying one way or another about parent income and IQ or their relationships. Okay, so go to the Visual Studio now. So as you should know, go to Start, Visual Studio. Okay, click that, and then you will have this Start page. So go to File, Open, Analysis Services Database. So this is exactly the same as we did in Bayesian classification last week. Okay, and the server, as you may remember, OIT-AP22, and find your database. Okay, do not choose somebody else's database. Choose your own. Okay, mine is PKIM. Okay, and then okay. Okay, so now we need to create a data source and data source views so that we can use the data from the database we just looked at in the Chapter 7 database. Okay, so go to our data source, right mouse button, new data source. Okay, and let's create a new one. Server name again, OIT-AP22. So as we practice for the Bayesian classification, data source is just a specifications for database access. So you have to specify server name and your authentication. In our case, we're going to use a Windows authentication. And the database will be Chapter 7, as we looked at just a while ago. Okay, always a good idea to test. So it looks fine. Okay. Okay. And next, username. Okay, don't type bkim, type your own username and the password. Okay. This one is the same username and password you used to log on to a university network. And let's give a good name. How about DS, data source? Okay, so now we create a data source to access the database. Now let's create a data source view. This one is just specifying what tables we are going to use. Okay, so let's create a new one. Again, right mouse button, and then create a new one, and next. And we're going to use a chapter 7 data source. Okay, and next. And we just use the whatever they already specified here. So next, let's choose everything. So you can individually select it. Okay. Or if you want to select the whole thing, can you see that double arrow? Okay, let's choose all of them. And next. Okay, again, a good name always help. Of DSV, data source view. Alright, so we have all the data now available to us for data mining. So let's look at the, we actually have data available. So we are going to use a college plans. So let's take a look. So go there, right mouse button, and then explore data. Can you see that? Explore data. Wonderful. So we have all the data available to us. Again, we are going to use these columns: gender, parent income, IQ, and the parent encouragement to determine whether the person is likely or not likely plan to attend college. Okay. And another one is we are going to use a parent income and IQ to practice regression. Let's create a mining structure now. Okay, go to our mining structure, right mouse button, new mining structure. Okay, next. We're going to use the relational database from chapter 7. So, okay, next. And we'll use DecisionTrees. Okay, so it's already selected, so you don't have to do anything. Okay, next. And we'll use chapter 7 data source view, which includes a college plans. Okay, so we have to specify which table. Okay, college plans. So here we need to specify columns for our data mining. So first, we have to specify a key, which is a unique value to differentiate every person or every student. Okay, so this will be our key. And then we need to specify which one we're going to use for input and predict. Okay, so we'll predict college plan, whether a person is likely to go to college or not, and we'll use as our input gender, IQ, parent encouragement, and parent income. Okay, so looks cool. Alright, and make sure we have the right kinds of data types. Okay, so text, IQ is integer, so long, text, long, and long. So sounds about right. Or you can actually use this detect functionality. So let's try that. So it looks okay anyway. So next. So we're going to use about 30% for testing. So actual data mining, we'll use the rest of them. So basically 70% of the data available. So let's give a structure name. college plans. Okay, so mining structure. So we're gonna use a college plans using what is it, decision tree. Okay. So let's allow drill through. Once you click this, you're gonna see the details, actually individual data later on. Okay, so let's check it and finish. Alright, so now we have a mining structure defined. So let's process it and let's see how it goes. Alright, can you see that the little icon here? So this one for the processing, so meaning we have to read the data and then do some number crunching. Alright, so what else? Run. So they're doing all the number crunching. So looks okay. Succeeded. Close and close. Alright, so let's look at these things. So mining model. Okay, this is exactly what we specified. So we're going to predict about a person's college plan using gender, IQ, parent encouragement, and parent income using decision trees. Cool. And let's look at the outcome. So they did some number crunching. So this all the data. So from all the data we have, about 67% not going to college, about 32% actually going to college. And then remember we did some entropy information gain in the conceptual part of this the discussion about decision trees. So first they chose parent encouragement as the most important factor, meaning information gain is the highest for parent encouragement. So let's take a look. So in this case, when parent encouragement is not there, and then 93% of those people do not go to college, and about 6.49% plans to go to college. And how about this one? So in this case, parent encouragement is there. In that case, about 43% going to college, not going to college, and 56% going to college. How about this one? So in case of parent income is greater than or equal to 74,610, and the parent encourage them to go to college, and about 99%. So 99% of people plan to go to college, and practically 0% not going to college. So basically, you can actually use these node as a rule. So you can actually create a rule such as if parent encouragement is there, and the parent income is greater than or equal to $74,610, and then there's a 99.94% of the likelihood or probability that person planning to attend the college. How about this one? So parents encourage the student to attend the college if their income level is somewhere between 43K and 66K, and then about 32% not going to college, and 68% planning to attend the college. Okay, so again, you can create another rule saying if parent encouragement is there and the income level is somewhere between 43K and 66K, and then about 68% of people going to or are planning to go to college. Or you can actually create another branches of a tree. Okay, if IQ is less than 100 or greater than 100, and then actually you can see 75% of people are planning to go to college. Again, you can create another rule saying if the parent encourages them, and then their income is between 43K and 66K, and the person's student IQ is greater or equal to 100, and then there are 75% chance that person planning to attend college. So you can actually create a very accurate rules about what may happen about students. Okay, let's look at a dependency network. Can you see that dependency network? Okay, this is just a graphical presentation of what they did in a decision tree. Okay, so by just moving this lever, you can actually find which one is more differentiating factor than others. So we actually did that using the information gains. Remember that? By calculating information gains, we can actually see which one is more important than others. Okay, but you can easily see that by this graphical presentation. All right. Now let's look at a prediction. Okay, again, we're going to look at accuracy stuff together with the mining models like Bayesian. We have to compare them. Okay, so let's go to this mining model prediction. Okay, let's go to a singleton query. Okay, there are two ways of getting prediction, as I told you last week. So you can do a singleton query, or you can actually use a database to make predictions about many people. In this case, let's use a singleton query. So let's just provide some input. So gender, let's say male, IQ about, I don't know, 25. Parent encouragement, not encouraged. Parent income, 85,000. Okay, and let's see a college plan, and run it. Okay. Again, there are three choices: design, query, and result. So if you press query, you can actually see this the SQL like the queries. In our case, we're gonna just see the result. So for that input we entered, then probably they will not go to attend college. Okay. So how about let's get more data? In that case, let's go to prediction function and predict probability. Okay. College plans. Okay. So for the input we entered, this is about 74% probability of this person not planning to go to college. Okay, so this is pretty cool. So this is actually this is consistent with the what we saw in the mining models. Okay, so how about let's change it. Gender, how about female, IQ 145, and parent not encouraged. Okay, parent income of 185,000. Okay, oh, still not going to college. Huh. Interesting. Okay, how about if I change it to encouraged, and parent income is, let's say, 45,000. How about that? Now it's applying to attend college with this probability. Okay, so all right, so let's try regression. Microsoft SQL Server provides a very powerful regression functionalities. So let's take a look. To apply regression, we need numeric data. So in this example, we have two columns of numeric data. One is IQ, the other one is parent income. So let's create a regression model to predict parent income based upon one numeric data, IQ, and the other qualitative data, including college plans, gender, and parent encouragement. Okay, so let's go to our mining models. Since we are going to use the same data, we don't need anything. We don't need any separate structure. So we can just add a new model within the same mining structure. Okay, so to do that, find this icon. Can you see that? Let me show you again. If you move your cursor slowly, the third one from the left is create a related mining model. Okay, did you find it? Create a related mining model. The third one from the left. Okay, and click that. Let's create a model using good descriptive name. So how about something like a parent income analysis using regression. Okay, we'll use Microsoft DecisionTrees. Microsoft DecisionTrees are actually very powerful because it provides the functionality of building a nonlinear regression instead of a simple linear regression. Explained a little later when we look at a mining model viewer. Instead of just using a IQ or one numeric data, we can actually use a qualitative data like a college plans and gender and others when you predict a parent income. But anyhow, let me explain that on the next the page. Okay. All right. Okay, so now we have a new model, parent income analysis, using regression. Okay, so let's look at these columns. So college plans, this time we're going to use this one as an input, and gender as an input, IQ as an input, but IQ is a numeric. These are qualitative. Okay, parent encouragement input, parent income. This one will be what we want to predict. Okay, all right, so it looks good. So predict input for these columns. All right, so let's process it, meaning let's read the data and crunch numbers. Can you see that the first one? Okay, the first one, it says process of the mining structure and all related models. Okay, and they want to save all changes. Sure, yes. Run. Looks great. Close it. Close it. Alright, so let's look at the model viewer. As you can see over here, they actually build the regression model for each node. Okay, so let's look at the one at the top. So this is basically a simple linear regression. And they show the coefficients over here in the regression model. So this one is intercept. If you're familiar with a regression model, so this is basically a y-intercept, and this is a coefficient for IQ. So IQ is an independent variable, and the parent income is a dependent variable. So as you can see over here, So basically you can say parent income is equal to 14,142.700 plus 266.501 times IQ plus error. Okay. The decision tree algorithm by Microsoft actually provides a nonlinear regression functionality. So let's take a look. So this one, as we saw here, shows a simple linear regression. Linear regression between IQ and the parent income. Let's look at these two nodes. So for this one is for students who do not plan to go to college. For this group, and they also provide a regression model here, like a coefficient. Basically, the y-intercept is 25,805, and then a slope is 91. So if you look at this one for students who do plan to go to college, actually you can see the different coefficients and the slope, like 35,821 and 161.840. So using this decision tree, the decision tree algorithm provides a nonlinear regression. Depending on the values of these qualitative variables, such as college plan, you can actually model differently. So let's look at this one. So if you look at this one, for people who do not plan to go to college, and parents do not encourage to go to college, and then they have this model, like 24,614, and then 86 for the y-intercept and the slope values respectively. And if you look at this over here, as you can see over here, there's no value for the slope. So what that means is there's no significant the contribution by IQ to predict the parent income. So basically, slope value is 0. Okay, so using these regression equations, let's predict a parent income. Okay, so let's go to a mining model prediction. Okay, and since we have more than one model, you have to select the right model. So go to select model. Okay, and we have to choose which one we're going to use. So we're going to use a college plans mining structure, and then we use this parent income analysis regression within this college plans mining structure as our model. So okay, so as you can see over here, the model has been changed. Okay, let's do some singleton analysis first. So how about college plan is plans to attend, gender, how about male, IQ, have 100, parent encouragement, let's say encouraged, okay, and then let's predict what would be his or his parent income, okay, so parent income. Okay, now let's make it just a little wider so you can actually see it. Okay, so let's run. So within based upon the values we just entered, the parent of that person probably makes $53,485. How about associated probability and other statistics? And to do that, we need a prediction function. Okay, let's choose a histogram so that we can see other statistics. Okay, parent. Actually, there's a space between parent and income, so be careful. All right, and then let's run. Okay, so the same amount of money, 53,485. But actually, you can find a lot more data here. And the probability that this person will make a $53,485 is about 99.9%. So pretty accurate. All right. So let's take a look. How about IQ of let's say, let's have a female and IQ of 140 and parent encouraged, okay, of discouraged or not encouraged, okay. So that person, this student parent probably make $39,163, and the probability is about 99%, so pretty accurate. All right. Okay. Thank you. Bye.